Hi guys, this is Mr. Rex. Today we're learning how to factor quadratic expressions using different squares. Okay. So the question won't be always factor completely. They're not gonna tell you how they're expecting you to factor. They're just saying factor. So in my case, the first step always will be do GCF. That will be the first step always. So I'm gonna try to see if there's a GCF here, but it's common factor. I check between the 32 and the 2. Remember, if I have a small number like a 2, I see if the 2 fits into the 32. It does 16 times, so that means the 2 is a common factor. Then I check the variables. If you notice, they're different. I have my first term an x, and the second term has a y, so there's no common variables. Therefore, my 2 is the only thing that is common, so I open my parentheses. Inside, I'm going to start dividing 32x squared divided by 2, which is a common factor, and that's going to give you 16x to the second power, which goes inside the parentheses. Minus, I take the second term, which is 2y squared divided by your GCF, which is 2. Here the 2's cancel, and I have a y squared as my answer. That goes inside the parentheses as my second term. And we're done doing greatest common factor. You have to keep in mind that they're asking you to factor completely, so you're not sure if you're done or not. So every time you're factoring, you always check the inside of the parentheses to see if there's anything that you can do. Now at this time I have 16x squared minus y squared. This is a difference of squares. Okay, so I'm going to give you some, explaining what is the difference of square. Alright, so let me explain what the difference of squares is. The idea is that you have a squared minus b squared. So technically this would be your difference of square. Why is it called a difference? Because you have a minus right there in the beginning. Why is it called the difference of squares? Because the a is to the second power, which is a squared, and the b is a square, b squared. So difference of two squares. That's where the name comes from. Now, how do I solve that? When you solve the difference of squares, you're going to have two factors, two parentheses, okay? And you're going to set the square root of the first one, square root of a squared is going to give you a, and you're going to put the a in the beginning of each parenthesis. And then you take the b squared as well, and you do square root of b squared, which is b. And that will go at the end of each parenthesis. Now, if you notice, you're going to have two signs. So let me go back again. You're going to have two signs. So how do you get the a and b is because you take the square root of a and you put it at the beginning. You put it at the beginning, a and a. Then you take plus and minus in the second parenthesis. And then you do the square root of the second one and you put it at the end, b and b. So that's how you solve it. Now let's review the steps that we have on the side. So factor the difference of two squares. Both terms must be perfect squares, meaning to the second power, perfect squares, and have a minus between them. They need to have a minus because the word difference means minus. Okay, so that's the idea. What else do we have on those steps? That is very interesting. Use two sets of parentheses. One's a plus, one's a minus. That will be the answer. One with a plus and one with a minus. Split up what it takes to make the first a perfect square and what it takes the second to be a perfect square, which is technically the same thing as square root. If you go backwards, that's what they're saying. If you go backwards and multiply, a times a gives you a squared. B times b gives you b squared. So that's basically what they're saying in the direction. Okay, let me give you an example. So I have here x squared minus 9. We know the difference of squares because he has a minus between two terms. He has a minus. And the first one is x squared. The word says square, so that's a perfect square. And the 9 comes from 3 times 3. 9, so that's a perfect square as well. Okay? Again, both have to be perfect squares. How do we solve this is the following. You take the first term and you bring it. You have x squared. And you take the square root of x squared. Okay, remember, when you're doing square root, technically here in the index, you have a 2. Inside the radical, you have a 2. Any exponent that you have with the x will divide that index. So again, let's bring the x. You have x. What about the exponents? 2 divided by 2 is 1. So square root of x squared is x. So I open my two parentheses. X comes first on both parentheses. Then I do the signs. One is going to be plus and one is going to be minus. Always different sign. One positive, one negative. And then I bring the 9 and I do square root of 9. Square root of 9 is 3. Why? Because 3 times 3 is 9. So square root of 3, that answer comes at the end of each parenthesis. So 3 and 3. And I close my parenthesis and that's my answer. X plus 3 times x minus 3. If I want to double check my difference of squares, I just need to multiply my first parenthesis times the second parenthesis. Once you multiply that, you should get x squared minus 9. You know what? Let's do it. Let's double check that answer. So we have x plus 3. Let's make a line over here. So I have x plus 3 times x minus 3. Okay? X times x, x squared. X times negative 3, negative 3x. 3 times x, positive 3x. 3 times negative 3, negative 9. And what I just did was I used something that is called FOIL. Okay? First, outer, inner, and last. Once I multiply all my terms, I notice that in the middle, I can combine like terms. Okay? So negative 3x plus 3x, they cancel out. 3 minus 3 is 0, they cancel out. What do I have left? X squared minus 9, which is the original problem here. So how do you double check your factoring? You multiply back and you should get your original problem. Okay? So let's go back to our previous problem. Here we go. So I said factor completely. We did a common factor, which was the 2. Then I said check the parentheses. And we noticed that we had a 16x squared minus y squared. Okay? So let's write the number again. I have a 2 right here on the outside, which I'm going to erase because now it's messed up. So I have a 2 right there. Difference of square, let's see. We check, and there's a minus in between. Then let's check the 16x squared. 16 square root is 4. The x squared is a perfect square. What about the second term? Y squared, so that's a square too. That means this is a difference of 2 squares. So let's solve it. Whenever we factor in, if I took a 2 as a common factor, that stays outside the parentheses. Now, because I have a difference of squares here, that's going to give me 2 parentheses. Square root of the first one. Remember, I have 16x squared. Square root of that, give me 4x. So that comes in the beginning of each parenthesis. Then I remember my signs. One is positive, the other one is negative. It doesn't matter the order, but they have to be different signs. And then I do the second one. And let's use, I don't know what color to use. Let's use red. I have y squared. Do not take the minus, all right? Only the y squared. So I'm going to do it here on the left side. Y squared. Square root of that is y. So that goes on at the end of each parenthesis. Every time you're factoring, you might want to check. Every time you're factoring, that's your answer, right? You might want to check the binomials. Remember, binomials, 2 terms that you have a minus in between, because that could be a difference of square as well. So difference, I see a 4 is a perfect square. What about the x? Is this a perfect square? No, because I only have a 1 right there. So as soon as there's something that is not a perfect square, then I know that this parenthesis is not a perfect square. So at that point, this is my final answer. Okay? Let's try one more. So the question here will be the same. Factor completely. First thing you do, you check to see if you have a greatest common factor. always, because that will make your life easier. So that will make your life easier. All right. It's gone. It's gone. All right. Common factor between the numbers. 8 is 4 and 2. 8 and 1. The 50 is 50 and 1. 25 times 2. 5 times 5. Common factor. I see that the 2 is my greatest common factor. So I'm going to bring that out. Quick question. Is the M common? It's not. Is the N common? It's not. You see, in order to be common, you have to have it on both terms. And they're not. So at that point, open my parentheses. First term divided by my common factor, which is 2. My answer, 4m to the 4th power. So that goes inside the parentheses. Minus second term, 50 n to the 6 divided by 2 is equal to 25 n to the 6. And that goes on my second term to the 6th power. Okay? That's my greatest common factor. First step. Next. I want to make sure that I'm done factoring, so I need to check inside the parentheses. So I come over here and check the parentheses. Oh, I have a minus in between. There's a minus, that could be a difference of squares. Let's check each term. 4, perfect square. M to the 4th, perfect square. Why? Because it has an even exponent. Every time we have a variable with an even exponent, that's considered a perfect square. Next, second term. 25 is a perfect square. N to the 6. It has an even exponent, so it's a perfect square as well. So that means I have one more step to do, which is a difference of squares. So there we go. Whenever we factor in again, remember, you have a 2 on the outside, so that 2 stays. Okay? Now, that difference of squares is going to give you 2 parentheses. All right? I bring down the 4m squared, 4m to the 4th power. Square root of that. Square root of 4 is 2. Square root of m to the 4th power. Whenever you're doing square root, you bring down your variable, and the exponent is going to be divided by the index. If there's no index, the little number inside the radical, if there's no number there, you have a 2 then. So 4 divided by 2, 2. So square root of 4m squared is 2m squared. Next. And that goes in the beginning of each parenthesis. Then comes my signs. Plus, minus. Next. I bring down the 25 n to the 6th power, and I want to do square root of that. So, square root of 25, 5. Exponent, remember, you have a 2 inside there. So that 6 is going to be divided by that 2. So I'm going to have n divided, 6 divided by 2 is 3. So your answer for that one is 5n cubed. 5n cubed. I check where I have my minus, and I see that the 2 is not a perfect square, so that means I can stop right there. My final answer will be this, including the 2 on the outside. Okay? All right, guys, review. And make sure you always check inside the parentheses. Okay? Take care. Have a great day.